Our next speaker is Mariana Montes from KU Leuven, and she's going to be talking about towards rich and standardized metadata in iRODS.
Hello, I'm Mariana Montes. I'm here from Belgium, and I'm part of the same team of Paul Borgemans, who presented yesterday about the Mango portal. So I'm going to talk about one of the main features of the Mango portal, that is the support for metadata schemas. Ingrid is also in our team, and she's there in person if anyone has questions during the coffee break. Okay, yes. So in this talk, I'm going to talk about the metadata schemas that we are trying to get our users to start using and how we support it within the Mango portal. The main focus of the talk is explaining what metadata schemas are, what our focus is, what problems it is trying to solve, and how we approach these problems, and a bit of what is the infrastructure that we offer around it, what we offer for users to create, manage, and apply metadata schemas, and how we solve different some of these problems with some of the technicalities, but it's more of a conceptual thing of what it is that we are doing. So this talk is organized based on three main challenges that we are addressing. The first one is how we can, well, how users can apply rich and standardized metadata in a system that has iRODS. So using the iRODS AVU system, this attribute value unit triples, that is also a flat system with a database, which is a great way of adding information and description about data, the data objects and the collections. How can we allow and encourage users to apply rich and standardized metadata? So first I'm going to explain why that is a problem and how we solve it. Another one, how we can even allow for hierarchical structure in the metadata, and also how the schemas are going to solve it. And then finally, I'm going to talk about the schema lifecycle, which is the solution to the third challenge, which is how can you allow for metadata schemas to evolve, but at the same time be stable and reliable enough to be applied in data within a research project. So in the first section, the question is, how can we support applying rich and standardized metadata in a systematic way? The problem is, suppose you have a very, very simple object such as this gray circle. That is your data object in iRODS, and you have someone in your team who's adding metadata and wants to indicate that it's gray. And there are a myriad of options on how you can annotate that. So even if you just want to say the color is gray, depending on your variety of English, you might use it with a U or without a U, and gray with an A or with an E. Maybe you prefer uppercase, or typo case or lowercase. Maybe you have a multilingual team, so you have someone doing it in Spanish, color gris, or in Dutch, kleur grijs. Maybe someone is very specific. This is not just gray, this is slate gray. And there you have spaces or camel case or snake case, and how do you register that? Maybe you have typos. You will always have typos. And maybe you're so specific that you want to use hex codes. So you have to meet with your team, or even if it's just yourself, you have to agree with yourself how you're going to annotate that, so that when you assign the metadata and then you want to search it, you know what you're looking for. And when you're annotating different elements of metadata, you still have this systematic way that works. So that is a problem. How do you solve that? And the other one is when you have richer metadata, you have a lot of metadata, you have a data object or collection that you want to annotate, and you're like, okay, what metadata am I supposed to add? So it's the color, but then maybe, I don't know, consistency, size, what metadata is going to be expected by my collaborators or by myself, what metadata I'm going to need, which one is recommended and which one is required, which metadata do I have to add? So these are all questions that can come up when trying to annotate. Worst, maybe the questions don't come up, only the problems afterwards. So we want to address them from the beginning by offering a system that, addresses these issues. So the schemas are translated into forms. So when someone is going to add metadata based on a metadata schema, what they're going to see is a form that has different things, such as, give me a moment, such as a drop down or a radio button. You can have checkboxes. You can have simple fields of specific kind of fields. Importantly, because you have a form, you already solve this problem of what metadata should I add, because you already have the list of all the metadata that is kind of recommended, and you have the asterisk that we all know from all those forms that we fill in every day that indicates that the field is required. So if someone finds this form and has to add metadata, they cannot save the metadata unless they have filled these required fields. So already having a form, which I think a similar thing was already mentioned in the RSpace talk before, of adding metadata based on a form, then you can force or encourage certain fields and people don't have to wonder about what fields they were supposed to do. What we are offering is not just the form, is also a tool to design the form based on the needs of your research project and your particular research objects. What you can add in that form is a field that has predefined options. So you can have the drop down or radio buttons or checkbox buttons where the user doesn't have to type. There is no way for the user to use a different language or to have typos or to use a different variety to specify something. You already, when someone designs the form, they decide what are the possible values for this metadata field, and those are the options that you have. So that is already taken into account by that. But maybe that is too restrictive for you and you don't really want specific values. You want, for example, a date, and then you just want to make sure that the date is always in ISO format, or you want an integer or a float, and you want to keep it in the range. For example, in this example, you can only enter a float that is between 0.8 and 8.6. You could have a text field that has a regular expression pattern, an email. There are different options. So you can add this kind of validation to your form, which still gives some freedom, but at least does restrict the possible values. The form also makes sure that the name of the AVU, the name of the attribute, is always consistent. So we have a name spacing system where you start with a prefix. In this case, it's MGS for Mango schema. But if, for example, you would like to use our metadata schema tool in a different space that is not the Mango portal, you could modify this so that you have your own prefix, I don't know, for Yoda, RSpace, whatever. Then separated by a period, you have the name of the schema. In this case, is block, and you can tell that there is a name for the schema and a title. So both for the fields and the schemas themselves, you can choose a name that is for the name that you have in iRODS, and then a more descriptive label for the user that makes a bit more sense. Huh? And then separated by a period, you have the name of the field itself. Here, for example, is color, and here's color with an uppercase. Here's width, and here is width with an uppercase, and also in centimeters. But when you design your field, you can decide what your label is going to be. If you add some sort of description, placeholders, defaults, you can make it much richer. So you add metadata on your metadata, basically. So this kind of prefix indicates that this is from a metadata schema, so it doesn't get confused with either AVUs that were added in a different way or from a different metadata schema. So the name of the metadata schema is unique within your research group or within your user, and the name of the field is unique within the metadata schema. And as you can see here, we are also supporting, because iRODS does, different AVUs with the same name and different values. So if you have a checkbox, someone can use different items, so you end up with different AVUs with different values. And for other fields, you can make them repeatable, which means that you click on this button and you get as many fields as you want to add different numeric fields, for example, that have always the same name and different values. Okay, this is basic implementation, so to speak. But then the namespacing allows us also to deal with hierarchical structure. So suppose that you want to annotate, give metadata about a book, but then the email of an author is not a property of the book, it's a property of the author of the book, which is a property of the book. So because iRODS in itself doesn't really support this kind of hierarchical structure, the system is flat, what we do is simply add another field inside a namespacing. So you have the prefix, the name of the schema, the name of the composite field, which is what we call this group of fields that represent the same property, and then the name of the subfield. So here again, we have this mapping between the hidden name and the name that is rendered. And when you're creating the form, you see it inside a box so that you know it's a unique thing. And you can also make those repeatable. So you could have different authors, which are composite fields. Then you will have MGS book author given name Paul and given name Mariana. And you want to know that Mariana goes with Montes and with these emails, and Paul goes with Borgemans and these other emails. So what we do here is use the units to bring the instances together for the same composite fields. So we don't allow units in any other context for the metadata schemas. We are using it specifically to identify when you have different composite fields, how they come together so that when you're searching, you know they're together. The idea is that the whole application, the whole tool that we are developing, which is available in GitHub, I have a link afterwards, supports the three stages, so to speak. So you have first an area where you're designing the metadata schema, where you can define the ID, the label, and then add as many fields as you need in whichever order. You can sort them, you can duplicate them to have a similar field and then work on it. You can keep editing, deleting them, and you can create different kind of fields as I showed before, the checkboxes. You can create then here a composite field in which you add the fields inside. You can save it and publish it, create new drafts, and so on. When you finish editing, then that becomes the form that a user is going to use to apply the metadata, which is the screenshots that I've been showing up to now. So you have the name of the element that you're annotating, and you can see the name as the user facing label. You don't see the other name, and you can see the different fields that you had already you are filling as you're filling your form. And then finally, we also have a way of rendering the metadata so that it's not just the name of the AVU and the value, but the label that is more friendly and informative. And when you have different values, you have them separated by commas. And when you have a composite field, it's inside a box so you can see. And also, if you don't fill the fields, if a field is optional, you don't fill it, it still shows up and just say that it's empty. So that you know that there is something else that could be filled. One thing that you might have noticed is that there is a versioning system. We use semantic versioning, but for now we only support major versionings until we figure out how to support others. But here, when you annotate, you can see which schemas version you used. You also see it in the form, and you see it when you're editing. And you see that this one is published. So this is the solution to our third challenge. What happens when you want a schema to be able to be implemented, but you also want a schema to be to move around? Like you have, maybe you make mistakes or the resource develops and you want to add new fields or edit them or something. You could make that every schema is editable and implementable. So the schema can change and then it's different, but then you have data that was already annotated with that old version and now you don't understand anything. Or you can make a new schema every time you make a change, in which case you have a lot of different schemas and they can have conflicting solutions with each other. And the first solution is really unreliable. You don't know what you're annotating with because you don't have a documentation of how that data object or collection was annotated. And the other option doesn't keep a history or a unity of a schema in itself. So the solution is a lifecycle. You can have a draft. The draft, you can edit it, you can delete it, but you cannot use it to add metadata. Then you can publish it and you can use it for adding metadata, but you cannot delete it or edit it anymore. If you want to delete it, it gets archived so that at least you can keep track of the story, of the history of the schemas. And if you try to edit it, you create a new draft of a new version. And then when you're annotating metadata, you can see the version that exists. And when you try to annotate it again, it's going to do it with the latest version and adapt to whatever is relevant for that. So with this life cycle, which is used in the part of manager, when you're editing your metadata schemas, we take care of all this, and it's much more organized and clean and documented. So to finish up with this, some technical specifications is quite simple in terms. So we have Python in the backend because we use the PRC to connect to iRODS, and vanilla JavaScript in the frontend. We use Bootstrap 5.2 for the forms and all the validation. And we use a JSON format that is based on JSON schemas, but it's not exactly like that, to save the information of the schemas, which are the instructions to create the forms afterwards. And if you want more information about how the JSON format is, you can ask in the Q&A or check out the slides, and there's more information. And you can also go to the GitHub repository, where you have all the documentation and a demo if you want to try it out. Thank you very much, and I'm available for questions as well as Paul now or later.
All right, thank you. Excellent. Are there any questions? We have a mic.
Yeah, I think I have two questions. So in the end, you said you do the meta schema validation with Bootstrap. So that means it's only in the front end in the GUI. So there's no validation in iRODS. Or...
Yeah.
Yeah. And then it's for the life cycle. So how do you deal with breaking changes in your schema?
What would you refer to as breaking change?
So for example, if you have the color red now as an option, and you say, okay, we're not allowed to use red anymore, so we'll skip red from the options, but you still have blocks of wood in the past that were red. So how would you deal with that?
So right now, when you open the form to edit the metadata of an element based on a metadata schema, it opens the form, it reads the existing metadata, and it tries to fill it in. So if the value is not allowed, it's not going to show up, and it's going to be deleted. So it's going to survive until you try to edit it again, and then it's going to respond to the new convention. So also, if you delete a field that existed, the field is going to be deleted. If you change the possible values, or it's not, for example, you have you added a regular expression that was not valid and now invalidates an old value, it's not going to let you submit it because it has invalid values. There are probably some, I don't know if edge cases or simply cases that we haven't thought of. So I don't think I have tried that particular case of having red among the options. You did?
Yes.
Okay, it was tested by my colleague and it works. Apparently, it gets deleted. So any value that is not valid anymore gets ignored. And once you have the, so it's something I didn't really mention, once you fill in that form, only the values that are in that new form are totally replace the previous values of the metadata that had to do with a schema. And also there is like a secret mgs.schema name __ version _ that tells you which version you use to annotate. So that, along with the new data, replaces the old data that had to do with the metadata.
Thanks.
All right. We had another question.
Hi, hello. I also have some question concerning about what kind of information you save about the schema on your collection.
Mm-hmm.
Only the version, the name, about because in Mass University we also use JSON schema to generate, and we took the option to save the schema in the collection, so you don't have that worry like if a value between version is not available more, you can always go back to the collection and you have all the information to always render about what you save about that collection and the metadata concerning the value.
I got a bit lost.
Yeah, I got it actually. But what we are doing is we're saving always the schema, so we're not deleting anything of it, and we're just recording a version which we can look always the correct version up again. So we have thought also about this idea of storing the schema directly with the metadata of a collection or a data object. But for now it's a bit too, yeah, we need to be conservative on disk space and database space, so we don't do it. And I would also to come back on that question on server-side validation. Basically, you have created a library for server-side validation.
Yeah, so so it's not currently implemented, but there is a Python library that can take a schema created with the Mango portal and a JSON object that has your metadata and validates the metadata, so the JSON contents against the schema and returns the AVUs as you would add them with the apply operations of the PRC. So that does validation via Python, and we would eventually plug it into the server side, but it's not the case right now. Right now it's only on the client side. Sorry, I don't hear anything.
He was saying there's a nice PyPy package that does JSON validation.
Yeah, but it does JSON schema validation, I think. And we don't use JSON schema. We use something similar, but the thing with the format of the JSONs, so for example, here you can see more or less the version of at the schema level, and then how we represent different kind of fields. We also have specific fields so for example, in JSON schema, the required attribute, whether a field is required, is in a list at the level of the schema, while in our case, we consider it as a property of the field itself. And we add some fields that are not really relevant for JSON schema, because what we are doing, so our JSON files are not describing JSON files, they are providing instructions to create a form. So because the goal is different from JSON schema as well, we are deviating a bit from that, and the JSON schema validator doesn't really help. That's why I did try.
So you have a custom validator for your format, and you've also implemented that in the server soon or coming.
Yeah. Indeed.
Excellent.
And it is available. So if anyone is interested in the Python library, we can also share that repository. It's also, both of them are open source.
I have one more question. Do you have some kind of sweeper or something that can walk the entire set of data that you're interested in to see anything that's now out of date or is no longer valid? I guess that's basically just running the validator in a loop.
Yeah, that would be, well, assuming, so that would be, there would be two things there. On one hand, there would be checking if all the data objects and collections in a project are annotated with the right version, so with the version that is published. That would be the easy way. Then there would be another problem of whether someone is corrupting the values by overwriting them with I-commands, for example, and then changing them to something that is not validated. And that would be something extra that we, for now, assume is not happening. But no, for now, we don't have anything, but it's, that is interesting for future work, to have a post-hoc validation of like everything is still okay. We don't have that.
Yeah, there's also, you probably are aware, there's a metadata guard rule engine plugin.
Yes, we consider that also.
So you can put your own namespaces in the protected space, so regular users would not be able to manipulate that type of information without going through, the approved process, or they can't just use an I command to change the content.
Yeah, this is also in our plans to implement.
Yeah.
At least from the moment that it really poses a problem.
Yeah, this is hard. Good job.
Thank you.